Let's look at example 2. We still need to find our big 5. However, I am going to give you a little bit of a head start. Remember that our domain is going to come from our denominator. So you do need to begin by factoring this denominator to find your domain. So let's factor this together, and then I'll have you pause the video and do it and try finding the big 5 on your own. So if I go to factor this, the first thing I notice is that they all have an x in common. So I'm going to take that x out that they all have in common. Now I'm left with a quadratic. So I need to multiply to 9 and add to -6. That's -3 and -3. So this is x and x minus 3 squared. So this is going to be our first problem that has multiplicity on it. We have our first even exponent. So now that you have 2 minus x on top and x minus 3 squared on bottom, pause the video, try finding the 5 rules on your own, and then come back to see how you did. Let's see how you did. Domain comes from the denominator, so I said the denominator cannot equal 0, and I got that. X-intercept comes from the numerator, set the numerator equal to 0, and I got 2, 0. It is odd because the secret exponent on this 2 minus x is a 1, which is odd. Y-intercept, plug in 0, I get 2 over 0. Can't divide by 0, so no y-intercepts. Vertical asymptotes, this is a spot where you may have messed up. Vertical asymptotes, don't forget you need to set everything in the denominator equal to 0. So I need to set this x equal to 0, and I need to set this x minus 3 squared equal to 0. So I have 2 vertical asymptotes, one at x equals 0, and when I took the x minus 3 squared, solved it, one at x equals 3. The x equals 0 one is odd because the secret exponent on that is a 1. The x equals 3 is even because the exponent on it was a 2, which is an even number. And behavior degree on top is 1, degree on bottom is 3, so that's our y equals 0 rule. And I graphed all of that over here. So now if we go to graph this, I know I need to go through my x-intercept because it's odd. However, same problem we had in example 1, I'm not sure if I should go through that way or that way, which means I need a starting point. So pick a number on either side of your x-intercept to plug in. I can't really plug in 3 because that's an asymptote. So let's go to the other side and plug in 1. So we're going to plug 1 into our equation. 2 minus 1 over 1 cubed minus 6 times 1 squared plus 9 times 1. By the way, you could plug 1 into the original or the factored. You should end up with the same answer either way. 2 minus 1 is 1. 1 minus 6 plus 9 is 4. So I plugged in a 1, and I got a 1/4 out. So I'm going to graph 1, 1/4. Whoa, hello, that's a negative 1/4. Let's put this in the right place. 1, 1/4. There we go. So now I know I have to go through that starting point, and now it's a lot easier to see what direction I should go through that x-intercept. So I got this. Over here, it's an asymptote, so I can either go up or down. Can't go up, or I'd make another x-intercept, so I've got to go down. Now this is an even asymptote, which means it should face the same direction on both sides of the asymptote. So if it goes down on one side, this even asymptote says I'm also going to go down on the other side. And then nothing between me and my star, so point. Other asymptote, only way up is to go up. If I go down, I make another x-intercept. This is an odd asymptote, so I go opposite directions. So since this is up, that is down, and then curve around to point to my star. And there you go. There's example number 2. In the next video, we'll move on to example 3.